Hello everybody, my name is Euler and today I'm going to do my presentation on Euler's method. So for part A, I drew this graph. We start at a known point x0, y0. At this point, the differential equation gives us the slope or gradient of the curve. This slope tells us how fast y is changing with respect to x at that specific point. Euler's method approximates the curve using a straight line. We assume the slope remains constant over a small distance. If we move a small horizontal distance h, aka the step size, the corresponding vertical change is approximately the change in y. This allows us to estimate the next point, x1 and y1. So how is the formula derived? We are given the gradient of dy over dx. We substitute h with the change of x. From the gradient definition, dy over dx approximately equals to change of y over the change of x. We rearrange that, change of y equals to h dy over dx. So the new y equals the old y plus the change in y. So we substitute the change of y into the formula, the previous formula, and we get this. This is Euler's method. We can take dy over dx equals to f(x) and y. So for part B, my spreadsheet contains 3 columns. I chose a step size of h equals 0.1, so the x values increase by 0.1 each row. The initial condition is y of 0 equals to 1, so the first row starts with x equals 0 and y equals to 1. In column C, I calculated the gradient using the formula x squared plus 2 divided by y. Next, I use Euler's formula, new y equals oy plus h times the gradient. As you can see here. So the next value of y is 1 plus 0.1 times 2, which is equal to 1.2. Then the next x value is 0.1. I calculated the new gradient using the new x and y values, then used Euler's formula to find the next y value. I continued this until x equals to 1, and we will use this number later. So these are the conditions we are given for part C. So firstly, we shift y to the left side and then dx to the right side, so we can integrate both sides. So this is the result after integrating both sides. So we apply the initial condition of y of 0 equals to 1. So x becomes 0 and y becomes 1. So we get the result of c equals to 0.5. After that, we substitute back c into the general solution. Then we multiply both sides by 2, so we can get rid of the fraction on the left side. So since y is more than 0, we just square root the whole of the right side. So then we find the value of y when x equals to 1. So x becomes 1, as you can see here. So y1 is equal to 2.3805. So to find the calculation error, we take the Euler result minus the exact result, which the Euler result we found from the Excel sheet at part B. So we got 2.4026 minus 2.38051 equals to 0.022. This is Wheeler. Thank you for watching my video on Euler's method.